Hello everyone, this is Grishma again from NVKST College of Education. So, last time we have seen about viscosity, right? So, today we are going to see about surface energy and surface tension. So, what is surface energy? What is surface tension? Shall we get into the lesson? You have always seen that when some insects are sit under water bodies, they don't sink. But when we are sit under sit something or stand a water body, we don't float. We will sink. Have you ever considered why? If not, this lesson will give you the answer for. So, surface tension. Tension is the tendency of fluid surfaces to shrink into minimum surface area possible. That some I believe that you have seen mercury, right? The white liquid that used in thermometers, and if you ever seen welding or soldering, you have seen that the lead. But when they come out, they form a structure like they are a small water droplets on the surface of a lotus leaf. You can also see that, right? In a lotus leaf, when you pour water, that won't get wet. Instant, they will form a small water bodies, right? So this surface tension of some fluids surfaces to string into minimum area to reduce their surface minimum area possible is called surface tension. Surface tension is can be defined as force per unit length acting perpendicular to the tangential line on the surface. So surface tension. What is surface tension? Surface tension is the tension on the surface film of a liquid. Consider that our liquid has an upper layer, right? So here also consider that surface tension is the surface film of a liquid caused by attraction of particles in the surface layer by the bulk of the liquid, which tends to minimize surface area. It is concerned with only liquids, as gases do not have free surface, right? Can you see a surface of a gas? No. But when coming to nitrogen, you can see that gas, but you can't see its surface. So this surface tension only deals with liquids. So what is surface energy? Same to surface tension. We know that in liquid, when we pour a liquid, you can feel it, right? Can you pour a glass of gas and see that they are all together? No. But when you take liquid, you can pour some and you can get into consideration that they are all close together. This is because we know that for everything, atoms is the building blocks for each and everything, and this in liquids it also comes the atom. These atoms stays all together because of attraction between the molecules, and they have given three diagrams. Consider that you have taken a beaker of water, and let's consider this a point inside the beaker. Okay, point inside the beam of water. Then I have given you three diagrams. Let's explain it one by one, shall we? Let's see what it is. So in the first case, in the first diagram itself, you can see it. So in the first diagram, you can see that here at the center, the arrow marks are pointed out to the other circles, right? That is, these atoms are so bonded together. This attraction by intermolecular intermolecules is what the atoms are attached to. Okay, this attraction will create a negative potential energy, which depends on number of atoms and number of molecules and distribution of molecules around the atom that have been chosen. So the heat of evaporation to separate, consider we have to separate it, so we have to heat it. This heat of evaporation is to be quite large when comparing to that of gas. Okay, for water it is of order 40 kJ per mole. So this is the second case. The second case is that we are going to, in the first case we can see that the diagram on the arrow marks on the left, that is inside it, and in the second case let's consider the particles on the surface of a water body. So in the surface, as the diagram indicates, you can see that this point is the molecule at that point is half attached to other molecules and half the upper half they are free. So comparing to the production of negative energy from all the waste filled molecule in the first case and the second case, we can see that the molecules on the surface possess more energy than molecules at the bunk. So next one, in liquid, we know that in liquid the molecules can be moving, right? When there is a stream of water flowing, then the water can be flowing. The liquid consists of molecules moving, but they can't be a perfect sharp shape. Have you ever seen that there's a liquid which is haven't frozen or making into solid have a sharp surface? No. So liquid consists of molecules moving, but they can't be perfectly sharp surface. Then the density of liquid rapidly drops to zero, and the direction indicates the distance of order of few molecular sizes. And I hope you have understood the lesson. Thank you.